Three conditions. Number one, for intersecting lines, we have to check whether it is an intersecting line, parallel line, or coincident line. So for that intersecting lines, the condition is for intersecting lines, condition is A1 upon A2 is not equal to B1 upon B2. No need to check C1 upon C2. No need to check C1 upon C2. Second condition, for parallel lines, for parallel lines, that is no solution. It is unique solution. Intersecting lines means unique solution. Parallel lines means A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2. Then these are parallel lines if this condition is followed. The third one is coincident line. A1 upon A2 is equal to B1 upon B2 is not equal to C1 upon C2. For parallel lines, there is no solution condition. Okay. And for coincident lines, A1 upon A2 is equal to B1 upon B2 is equal to C1 upon P2. Okay. So these are the conditions that we have seen in our textbook. Also, you can find these conditions. Intersecting lines A1 upon A2 is not equal to B1 upon B2. Coincident line all equal, and C1 upon C2 is not equal, then they are parallel lines. Okay. Now we will have to check the conditions for the given pair of lines in question number 2. So first question number 1 is 5x minus 4y plus 8 is equal to 0. Equation number 1. This is equation number 1. 7x plus 6y minus 9 is equal to 0 is our equation number 2. So as I told you, what is A1? A1 is here coefficient of x in the first equation, that is 5. A1 is 5. B1 is the coefficient of y in equation number 1, B1, and C1 is equal to 8. C1 you have to take left side and then write C1 value and C2 value always. A2 whole equation should be written left hand side. B2 is equal to 6 and C2 is equal to minus 9. Now we have to check which condition should be followed. Find A1 upon A2 first. Find A1 upon A2. A1 upon A2 is 5 by 7. Okay. Now find B1 upon B2. B1 upon B2. B1 is minus 4 upon 6 minus 2 to the 4, 2 to the 6. So they are not equal. 5 by 7 is not equal to minus 2 by 3. Obviously, it is negative, positive. They cannot equal negative, positive. So therefore, we got A1 upon A2 is not equal to B1 upon. So we have to find out whether the line representing the following pairs of linear equation intersecting at a point. So the lines are intersecting at a point. Lines are intersecting at a point. Okay, like this we have to take. Second also we have given the second question as 9x plus 3y plus 12 is equal to 0, and 18x plus 6y plus 24 is equal to 0. So here a1 is equal to 9, b1 is equal to 3, and c1 is equal to 12. a2 is equal to 18, b2 is equal to 6, and c2 is equal to 24. So first find a1 upon a2. a1 upon a2, find first a1 upon a2. a1 upon a2 is equal to 9 by 18. So 9 ones are 9, 9 to the 18, 1 by 2. Now find b1 upon b2. b1 upon b2 is equal to 3 by 6. 3 ones are 3, 3 twos are 6, 1 by 2. And c1 upon c2 is equal to 12 by 24. 12 twos are 24. So we are getting all equal. So since a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. Therefore, the lines are coincident. They are coincident lines. And the last one is third question. 6x, 6x minus 3y plus 10 is equal to 0. As I said, if the 10 is right hand side, given in the question, you will take the left side all the numbers. This is equation number 1. Equation number 2 in mind, 2x minus 5 plus 9 is equal to 0. Okay. So all numbers should be taken left hand side. Then you can write a1, b1, b1. So a1 is 6 here. And don't forget to take the sign. This is not 3 minus 3. b1 and c1 is equal to 10. Similarly, a2 is equal to 2 and b2 equal to minus 1 and c2 is equal to 9. So now find a1 upon a2 first. a1 upon a2 is equal to 6 upon 2. So 2, 3 is 6. 3 we got. Then find V1 upon V2, that is minus 3 upon minus 1, minus minus cancel, again you got 3. Now check C1 upon C2. C1 upon C2 is equal to 10 upon 9. That is not equal to 3. So we got the condition A1 upon A2 is equal to B1 upon B2, but not equal to B1 upon B2. B1 upon A2 is equal to B1 upon B2, both 3, and this is equal to 10 upon 9, which is not equal to 3, so is not equal to C1 upon C2. Therefore, the lines are parallel. Therefore, the lines are parallel. No solution. So here intersecting line means it will have unique solution. We can solve this. These equations will have unique solution, and here they are coincident. So this having by the many solutions is called infinity many solutions, and when the lines are parallel, no solution condition. So these three conditions are very important. It should be followed. So now we have to check the consistency, and same exercise we are doing. So question number 1, we have to check the same way. We just check whether it is consistent or non or inconsistent. So for example, 3x plus 2y is equal to 5. So bring 5 on left hand side, then you can say this is equation number 1. So 3x plus 2y minus 5 is equal to 1. This is our equation number 1. And second equation is 2x minus 3y is equal to 7. So you have to bring 7 on left hand side. So 2x minus 3y minus 7 is equal to 0, equation number 2. Now check A1 upon A2, B1 upon B2, C1 upon C2. So here A1 is equal to 3, B1 is equal to 2, and C1 is equal to minus 5. A2 is equal to 2, B2 is equal to minus 3, and C2 is equal to minus 7. Okay. Now check A1 upon A2. A1 upon A2 is equal to 3 by 2. And find B1 upon B2. B1 upon B2 is equal to 2 by minus 3. They are not equal. So which shows that A1 upon A2 is not equal to B1 upon B2. That means these are intersecting lines. Some graph is intersecting line and it has unique solution. That means this is consistent system of equations. Therefore, is having solution means it is consistent. Is consistent system of equations. Okay, so we have to do all the questions like this. The second question I'm leaving, third one, take the third one. So question number 3 is, whenever you have given in the fraction, what will you do? 3 by 2 x plus 5 by 3y is equal to 7. This is equation number 1. But we can do directly also 3 by 2 A1, but it can create a problem in calculation for you. So better to convert into the fractionless quantity. So left side, if you take LCM, first you take LCM 3 to the 6. So this will become 6, or you can multiply this by 3 and this by 2. So this will become 6, and 2 3 is 6, 3 3 is 9. 9x plus this 2. 2 will multiply with 5. 2 5 is 10y. You can say these are the prime. 3 2 is 6, 3 3 is 9, and 2 5 is 10. And this 6 will multiply on the right hand side. So we get 9x plus 10y is equal to 7 6 is 42. So this will be our equation number 1. So like this we can change into fractionless quantities. Okay. Okay. Then equation number 2 is already given us as 9x minus 10y is equal to 14. So just minus 42, you have to take left side. Minus 42 is equal to 0. Minus 42 is equal to 0. And here 14 is taken left hand side. Minus 14 is equal to 0. Equation number 2. Now check the condition. A1 upon A2 is equal to 9 upon 9. That is 1. And B1 upon B2 is positive and this is negative. So 10 upon minus 10, which is equal to minus 1. So they are not equal. So therefore, A1 upon A2 is not equal to B1 upon B2. So it is also a consistent system of equations. Therefore, it is consistent system of equations. Consistent system of equations. There are three things you have to remember. If the graph, three things comes when you are having this condition A1 upon A2 or any condition, three things. It reveals the three things. One, the graph will be intersecting lines. Graph, okay, intersecting lines. Second, it will have unique solution. It is telling about the solution, means we can solve unique solution. We can solve. And third is it is consistent system of equations. Okay. So every condition tells three things. One, about the graph. Before drawing, we can say what will be the type of graph. Second, about the solution, we can solve or not. Third, it is consistent or not consistent. Consistent or inconsistent system. So these three things we can say from the given two equations. And we can solve whenever it is unique solution. We can solve, otherwise we cannot solve. Other two conditions we cannot solve. Question number 4, we have to check and then solve graphically. Graphical method, I told you how to do. I've done in the previous question. Just first check. Question number 1. X plus y is equal to 5. So we can write x plus minus 5 is equal to 0. Equation number 1. And 2x plus 2y minus 10 is equal to 0. Equation number 2. A1 upon A2, check the condition. A1 upon A2, I'm putting directly in values. You could write here A1, B1, C1, A2, B2, C2, 1 by 2. And again, B1 upon B2 is also 1 by 2. B2 is 1. And B1 upon B2 is minus 5 upon minus 10, that is also 5 under 5, 5 to the 10. So this condition is for since we got A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2. Therefore, lines are coincident. Lines are coincident and it is consistent is consistent system of equation is consistent system of equation because infinitely many solutions. You need constant lines and it has infinitely many solutions. You could write this also in many solutions and it is consistent system of equations. So we cannot solve by other method and in graph also we can draw only one line which will represent both the lines. So coincident lines. We will draw only the lines which are intersecting. So here we cannot draw the line because if it is consistent also obtain the solution we cannot obtain for infinitely many solutions. Only for unique solution we can obtain the solution. Okay, it will have infinitely many solutions. Only we can write it as infinitely many solutions. As many solutions. That's all.